So hello, welcome to Fueling the Transition, the podcast series from AFRY Management Consulting, where we're dealing with everything to do with the energy transition, and that includes, of course, decarbonisation, digitalisation, decentralisation of the energy industry. And in that context, of course, one of the very hot topics right now is hydrogen. And that's because when considering decarbonisation of industry and of the heat sector as well, it's a more challenging situation, I would say, than where we are really with electricity in and of itself. So I'm very pleased in that regard to be able to talk today to Johan Leuraers from Equinor. And Johan is working in the area of government and regulatory affairs in Equinor. And just perhaps before I introduce Johan and my colleague John Williams, I would say that Equinor is a broad energy company based out of Norway, has a history in oil and gas, but looking forward is doing so much more than that, and is a big, it's a big company as well, 21,000 employees, 30 countries worldwide, and some really interesting developments, but both in renewables, which we probably won't touch upon too much today, but in new areas in hydrogen, in CCS as well, which is the focus of the discussion today. So with that, perhaps I would say hello to Johan and ask you if you wanted to add anything about Equinor.
Thank you, Matt. Thank you for having me. And it's really a pleasure to be able to talk a little bit around what we call our low carbon solutions, which is very much geared towards CCS and hydrogen solutions going forward in order to help decarbonize the economy. But I think you gave a pretty fair and good introduction to the company. Thanks for that.
Thank you. And with me is my colleague, John Williams, who's been focusing on hydrogen for some time. He's a senior principal in Oxford office. Hello, John.
Hi, Matt. How are you? And pleasure to have Johan along today. We've been talking to Equinor for a number of years on various projects, and it's great that all our stars align when we talk about hydrogen. So looking forward to a good discussion today.
Excellent. Thank you very much. So I'll kick straight off and say, John, Johan, hydrogen, is it essential for decarbonisation or is it just a lot of hype?
Well, I think there's a very easy answer to that. I think the answer is yes, it is essential to decarbonisations. Usually when we talk about hydrogen, we think about its use in a number of sectors, which you've already mentioned, in industry, heat, mobility and power. And in some of those sectors, there are alternatives, and the alternative is usually electrification. And now in some sectors, such as mobility, electrification will play a prominent role, particularly in battery electric vehicles. But in other parts of mobility, it's going to be very difficult to electrify. For instance, in heavy truck transport, in maritime transport, and potentially hydrogen also has a role in aviation as well. But when we think about industry, we think about industrial heat, but also we think about industrial feedstocks for hydrogen. And here hydrogen has a irreplaceable role, for instance, in the production of ammonia, of other chemicals like methanol, and also in refineries. So there is no alternative there. We have to decarbonize the hydrogen supply into those industries. So it's a really important sector for us to think about.
Yeah, I would really second that because, for quite a while, from the traditional oil and gas perspective, we really have been positioning gas as a means to decarbonize. And for many areas in the world, that is actually still a reality, by displacing coal, but particularly in Europe, which is at the forefront of the decarbonization effort and the climate transition, where arguably we have a large exposure because so much of our gas goes into that market, that context really forced us to think about solutions beyond natural gas. And what we see is this accelerated ambition to reach decarbonization targets faster. The whole discussion is around 55% by 2030. That in combination, so net zero, anyway, the net zero ambition with the accelerated timeline, it's very difficult to conceive that is possible at all without thinking about hydrogen and CCS particularly. So our company has been at the forefront of developing solutions there already quite early. And also in the ETS market, many industries are now starting to feel the price levels, and free allowances are gradually less and less available. We see more and more action also from industries reaching out to us to find solutions to decarbonize the energy intensive side and the heat business. So it's really out there in the market. We get a lot of calls for help on that.
Thanks for that introduction. And John, just for people listening, there seemed to be a lot of discussion about different colors of hydrogen these days, and some of the descriptions changing now. I wonder if you could just sort of outline the different types of hydrogen that people talk about, just so later, if we talk about it, people know what we're talking about.
Okay, so all existing hydrogen production, well, probably a very, very high percentage, about 96% of it is produced from fossil fuels, so gas or coal. And in the production of the hydrogen, the carbon that is a byproduct, the carbon dioxide, isn't captured. So it's released into the atmosphere. It's responsible for quite a lot of emissions. So there is a tendency to call that type of hydrogen grey hydrogen. And this is the type of hydrogen that we need to replace in existing applications. And so then we talk about other colours, such as the main ones being blue and green. So blue hydrogen is hydrogen produced predominantly from natural gas, but here the carbon dioxide is captured. So if you have methane reformation to produce hydrogen, you would then attach carbon capture and storage to that process. So the carbon is captured, not up to 100%, but can get up to a pretty high percentage, 95, 96%, depending on which technology you use. But that is what we normally call blue hydrogen, or low carbon hydrogen, which is the new EU classification for that type of hydrogen production. Then the other one that most people are talking about currently, particularly in some of the European strategies, is renewable or green hydrogen. And green hydrogen is produced when you use renewable power in an electrolyzer. So you use the process of electrolysis with water to produce hydrogen and oxygen. And as long as the power source is from renewables, then it is classed as renewable or green hydrogen. And we need to be a little bit careful when talking about electrolyzers, because it's not as simple as attaching an electrolyzer to an electricity grid. If you do that and there are fossil fuels in the power mix within that grid, then the hydrogen you produce will have a greenhouse gas emission associated with it. So the safest way to produce green or renewable hydrogen is just to use renewable power. There are some other colours, however. Turquoise has been talked about, which is another method of producing hydrogen from natural gas. And this is through the process of pyrolysis. And the German strategy is called this turquoise. There is also yellow hydrogen, which is hydrogen produced from nuclear power. And we'll probably see some other colours come along as well. But the EU classification now talks about fossil fuel hydrogen, equivalent to grey, low carbon hydrogen, equivalent to blue and turquoise, and also grid connected electrolysis, and then renewable or green hydrogen.
Wow. So that's a fairly complicated picture for people to get to grips with. And the majority, as you say, the majority of hydrogen today getting produced is what we would classify as grey hydrogen and getting used in all sorts of industrial processes. Okay, so having established the background on hydrogen there, maybe Johan, you could, you mentioned that Equinor's been at the forefront of promoting hydrogen projects. Maybe you could tell us a little bit more detail on what's going on, some of the developments there.
Yeah, of course, and it is indeed quite a rainbow. So we try to not get too much stuck on to that discussion. But what we have been looking at, in addition to cleaning up our own emissions, you could argue, in the context of trying or aiming to be a zero emission company by 2050, we have then also been looking at how can we help our customers get their emissions down. And so in that regard, we have always been looking at combinations of basically decarbonizing gas, because that's our legacy, if you like. So how can we offer a product that our customers can use without emissions, or how can we help customers get rid of emissions that they do have from industrial processes. So that's why we have been basically developing CCS solutions as well as then blue hydrogen solutions alongside, and we believe that they marry up pretty well together. And I guess at this point in time, UK is probably one of the prime examples where there's a very pragmatic, or there appears to be a very pragmatic view on decarbonization, and that's what we would like to see also in other policies, that there's more focused on getting the greenhouse gas emissions down rather than what is the origin of the energy. And particularly in the UK, we are really working within the Humber region and H2H Salt End and zero carbon Humber, where we are focusing into industrial clusters and trying to find out how we can assist on getting those areas decarbonized. In Norway, you could say that also the Norwegian authorities have been very keen on supporting a project that we call Northern Lights, which is basically developing an open source or an open access full carbon capture and storage value chain. The whole project revolves around a capture part where a waste to energy and a cement plant would probably be capturing about 400,000 tons of CO2 emissions a year. Then the transport piece of that project is about one ship per capture plant that would then transport those that liquefied CO2, if you like, for about 700 kilometers to an onshore terminal, where then a 110 kilometer long pipeline will pump the CO2 in underground storage 3 kilometers under the seabed, and all of those components, they are built to grow, right? So at the outset, the phase one, we would have the ability to store about 1.5 million tons a year. In a phase two, that can be expanded with another 3.5 million, such that we would be able to ramp up to 5 million tons if the market is ready for that. So we're really looking at things in a very comprehensive manner, developing CCS as well as blue hydrogen, whatever is in a way best fitted to serve the needs of the industries that want to operate in a lower carbon environment.
And so the concept behind that is, if I've got CO2, I've brought it to a port, Equinor will take the CO2 and deal with it thereafter, take it
That's correct.
to the Northern Lights site and store it long term and be responsible for that CO2.
That is indeed the entire idea. Yeah.
Excellent. So, in terms of Equinor's experience in putting CO2 into the ground, of course, you've got a long history of that at Sleipner. How long has that been going on?
That's been going on for more than 2 decades, and actually the type of storage that we do, amongst others in Sleipner, is also related to enhanced oil recovery, and you will find more of those examples also in the US, etc. The type of storage that we are doing in Northern Lights, it's very different. So this is not CO2 that is destined to be used for anything other than staying safely in the geological structures that we have identified that are suitable to store this for the long term. Right? So there's no enhanced oil recovery attached. There is no other use for this CO2 other than just staying underground.
So you're finding you're looking at a site here which has been found purposefully with the idea of putting the CO2 there and keeping it there.
Exactly. Our colleagues with the geological experience and know-how, they are then able to identify areas where it is safe and where all the conditions are met to keep the CO2 underground and within the geological structure. And then there's also, of course, tools that can monitor that the product is actually there and staying there. So we can literally visualize where the CO2 sits underground.
Yeah. So the other thing I've heard about mentioned is from the Norwegian government, this concept of Longship.
Yep.
And I assume that's not once again Vikings coming over to the UK and other places. Maybe you could just tell us a little bit about what Longship really is.
I certainly hope not, but Northern Lights and Longship, they are connected, while Northern Lights is really diving into transport and storage of the CCS value chain. Longship is then the code name or the project name for the capture bit, where the Norwegian government is also supporting the waste to energy as well as the cement factory to get the capturing solution in place, because neither transport and storage or capturing is economically viable or is commercial at this point in time. So there is a need for public support to get these concepts off the ground. And that is probably one of the main challenges still, that basically the economical framework, the level of the carbon price, if you like, is not at the level whereby those solutions can be developed from the ground up, only supported by a carbon price mechanism. So there is some additional investment support needed, and then over time, as also CO2 prices increase, we believe that one could operate those solutions within an economical context where if the CO2 price is sufficiently enough. I think to give you an indication for the piece, the transport and storage piece, we can probably do that at market conditions within a price range between 30 and 50 euro per ton of CO2. But that excludes the capturing bit, just to be very clear on that.
Yeah. So it's a little bit like I see here hedging your bets a little bit in terms of decarbonisation of industry. For instance, you could either convert industry to using hydrogen in lots of processes, or you could do capture of CO2 on the back end, if you like. And either way, your Northern Lights project here is really open there to take the CO2 in whichever way that we're developing. And I would imagine we'll be doing a bit of both in depending on the nature of the industry.
Exactly so. So actually, the customers have the option, and then it's basically an economical calculation. What is the cheapest and best way to do it? Either capture CO2 from the flue gases or from the operational or industrial processes that are ongoing, or do you upfront take out the carbon before you use the product? And we can basically support either. We also think that by not necessarily focusing on colors and origin of hydrogen, at least at this stage, that more focus should go to get this economy going, and the volumes that we can achieve and ramp up in a very quickly through the solutions that we are proposing, they could lay the foundation for more and more renewables coming in. So it's definitely not so that we are opposing hydrogen coming from renewable electricity or anything like that. That's definitely part of the solution, and certainly within Europe, the end goal for sure. But it's very hard to do everything at the same time. So if you want to have an economy based on renewable energies only, and you want to do you want to be there, you want to decarbonize at a very fast pace, we don't think that is compatible if you do not also include decarbonized products that may have a fossil fuel origin. And that's why we think more focus should be laying with greenhouse gas reductions rather than all the color coding around hydrogen that John was just explaining.
Yeah. Okay. So then, thinking about this and coming back to the hydrogen part of it again, John, maybe your view on, is one sort of hydrogen better than the other in this context from your perspective, and then also perhaps going on to think about what are the barriers. Let's say this Northern Lights is in place. There's renewable electricity coming on as well. What are the barriers to the take-up of hydrogen itself?
Sure. I think I'm probably in quite strong agreement with Johan, actually, that if we think about the goal of achieving net zero, we don't have to wait until 2035 or 2040 when green renewable hydrogen might be more readily available and might be more competitive. If we can do it quicker, then why can't we do it quicker? Surely that's got to be for the benefit of everyone. If the way we can help to scale up the hydrogen value chain and to start incentivizing hydrogen demand, both in existing uses of hydrogen and potential other uses of hydrogen. And we can do that through a method of production of hydrogen which can be scaled up and which can be cheaper, if we can use that word, in the short to medium term, then I think that's what we should be doing. And let's keep in mind that, the ultimate goal of decarbonisation and of all the attention and all the effort is to get us to net zero. So let's do that in the best, most efficient, technology neutral way that we can. And then just to answer the other part of your question about the barriers, from my thinking, the main barriers are the economic barriers currently. Both blue and green hydrogen are currently more expensive than grey hydrogen. So in order to incentivize those users of hydrogen currently to switch to low carbon and renewable hydrogen, there needs to be some incentive for them to do so. As Johan's just explained, the current carbon price through the ETS isn't a sufficient incentive. So either we need to reform the ETS, we need higher carbon prices, or we need some other kind of support mechanisms in place, which could come through, for example, carbon contracts for difference, which have been talked about by the EU and also in the German national strategy. But really, it's bridging that cost gap, both for existing users of hydrogen and for users of natural gas, for instance, when we then think about replacing natural gas as a heat source. So that's the real challenge, is trying to incentivize demand and then to look at what is the best, most efficient way of producing the low carbon renewable hydrogen. And then we also need the value chain. We need the supply chain to scale up as well. And it's not just about production. It's not just about demand. We also need the transport and storage parts of the value chain to scale up as well. So to get from where we are now to where the ambition is, there's a lot of work to do on the production, the logistics, and the demand side of the equation.
You mentioned contract for difference. So there are other support mechanisms, Johan, that you could imagine might come forward to support hydrogen?
Definitely. I mean, an area where we think that needs to be really developed fast is basically the whole infrastructure and develop the infrastructure. John already alluded to the transport and storage, and somehow we can draw parallels with the development of the gas infrastructure. And then, of course, there's also a lot of thinking already within the EU how some of that gas infrastructure can either be repurposed or, if we can put in blends. These are typically very large investments where some degree of socialization of costs will need to happen. Generally, we concur also with what John said. The most important part here is to basically get this market up and get demand up, and any type of support mechanism that we can bring towards the customers in terms of demand side support mechanisms, whatever their name then is, that would be very, very helpful. I think particularly in the EU, where there is where the import dependency for energy is so high, I think people and authorities will generally be reluctant to come forward with support on the production side because that, with the exception perhaps of the buildup of an electrolysis value chain where Europe has more indigenous know-how and opportunities. But I think they will be very cautious to shift monies outside of Europe's outside of the borders of Europe. So I think the best way we believe is also to try and come up with incentives that make demand pick up. Solutions there could be it's not necessarily our favorite, but it's definitely part of the solution, is to look at potentially blending of hydrogen in existing gas grids. That is also a way to quickly beef up demand, and it's certainly a way that France tends to look at the solutions. While another example perhaps is the Netherlands, where in the phase out of the Groningen production, there are plans to use what then is called the low calorific gas grids, which is a physically separated grid from a high calorific gas grid, to repurpose that gas grid into a hydrogen backbone connecting the industrial clusters in Netherlands, and then potentially also connecting out to Germany, Ruhrgebiet, or to Belgium, Antwerp Harbor, where you find a lot of chemical industries, etc. So infrastructure support and demand management incentives, that would be very welcome.
We talked there a little bit about mixing and transport and so on. John, what's the maximum amount of hydrogen I can put in my current gas grid?
Well, there's a lot of research going on at the moment. Current estimates, or the higher level estimates, are around about 20%. So you could blend 20% of hydrogen by volume with natural gas. And the limiting factor on that is end user appliances. So once you go beyond that 20%, by the time it gets to the end user appliance, you would need to change the burners in those appliances. So they can cope with a blend of 20% by volume. But remember, by volume, and 20% sounds like quite a lot, because the energy density of hydrogen is about a third of that of natural gas. It would only result in probably more like a 4 or 5% reduction in emissions due to that 20% blend. Once you go beyond that 20%, you then have to think about converting the appliances, and then you can make the jump from 20% to up to 100%. And then you need to think about whether some of the transmission, some of the distribution networks will need some work to enable them to be converted to handle that 100% mix of hydrogen.
With a much bigger volume of gas moving around by the sounds of it.
Well, in terms of the overall volumes, the overall volume would stay the same, because if you've got 100%, 20% of it hydrogen, 80% of it is gas.
Oh, I meant in the 100% case, if the energy density is so much lower, and I want the same heating in my home, how does that work? I don't know.
I guess you would end up burning a bit more volume of gas in order to get the same energy out of it.
Yeah, and you would also need to adjust the pressure in the pipelines to probably get sufficient energetic value across. And I just want to maybe allude also to the blending. I think John made a very good point. So if blending for the purpose of blending, we don't think is a good idea. So if you start out with blending, there really has to be a kind of a purpose or a target to want to go for 100%. Blending hydrogen into the gas grid up to 20%, that is indeed the number that we also hear for decarbonization purposes. That's a lot of money for fairly little effect.
Yeah.
Right, so that's the decarbonization. I don't know the exact numbers, but probably if you blend up to 20%, you probably achieve a decarbonization of maybe up to 7%. So it's you would want to think twice.
Yeah, likely to be a costly route by the sounds of it.
Indeed.
And is there any impact? Does hydrogen corrode the pipes? Does it matter what sort of pipes we've got here?
It certainly matters, and that is why the question on what can pipes take is so difficult, because it very much depends on the age and the materials that one has in the distribution system, particularly if you're thinking about decarbonization of buildings or heating in buildings. It varies dramatically from one country to the next, and even from one city to the next. So it's very hard to kind of give an average there. But the pipes and the quality of the pipes and the joints and the compressors, those things do matter, and they will need to be looked at.
John, what if I don't have pipes? What do I have to do then? Can I? Is it like LNG? What's my option?
So hydrogen can be transported. Pipes we've talked about. It can also be transported by truck, but that does turn out to be quite an expensive way of doing it per kilometre. Over longer distances where pipelines or new pipelines wouldn't be economic, for instance, long subsea pipelines are very expensive, then a lot of attention is being put into looking at various forms of transporting hydrogen or its derivatives over longer distance. So think about, for instance, some of the big projects being talked about in the Middle East. So they can produce hydrogen at a very low cost because of the abundance of renewable resources there. The options to then transport that hydrogen to Europe, for instance, or to the Far East could be to liquefy hydrogen, and then you transport it in its liquid form. The problem with that is it needs to get down to, I think it's over minus 260 degrees C, which takes a lot of energy to do. And also you need to keep it at that temperature. So it's quite an energy intensive, less efficient way of transporting energy. It's also possible to convert the hydrogen into ammonia. And this is the focus of one of the big green ammonia projects, the NEOM project in the Middle East at the moment. You produce the green hydrogen, you convert it into ammonia, you then ship the ammonia, and it requires a much higher temperature to liquefy. So I think it's around about minus 50, minus 55, so less energy intensive to do that. It means you lose less of the energy through boil off in the transportation process. When it then reaches its destination, it can either be used as ammonia or it can then be converted back into hydrogen. If you use it directly as ammonia, then the costs aren't as high, but if you're converting back into hydrogen, then that adds another element to the cost. The third way that people are talking about is attaching the hydrogen molecule to a carrier molecule. And so this is the liquid organic hydrogen carrier method of transportation. So at the source where you produce your hydrogen, you then attach it to the carrier molecule, you ship both molecules joined together, and then you de-link them at the other end, and then you send the carrier molecules back. Again, there are costs involved in the at both ends in attaching the molecule, detaching the molecule, and the transport. So there's no cheap way around the long distance transport of hydrogen. And so for some of the larger export projects to work, they'll need to be producing their hydrogen at a very, very low cost in order to make that delivered cost of hydrogen competitive with hydrogen that can be produced locally.
Understood. Good. So moving on perhaps to some of the targets that have been talked about in Europe. We've got 10 million tons of renewable hydrogen and 40 gigawatts of electrolyzer capacity by 2030. I think probably you've partly answered this earlier on, but what do you think of those targets and how easy they are going to be to achieve?
They're certainly extremely ambitious when we look at it. And in addition to the ambition on production and electrolysis capacity, what concerns us most, if we look at these elements, is the effects or the requirement that puts on additional development of renewable electricity. Because in those, well, at least in the strategy, the original document in the EU, they are pretty adamant to zoom into renewable-based hydrogen only, and I think that will be extremely, it will be very, very difficult to achieve that, because we have to remember that not all electricity is decarbonized already, and just building out bespoke offshore wind solutions or solar solutions for the production of hydrogen, that might get in the way of better use of those clean electrons. So it's great in a way that EU puts forward very strong targets on renewable development, But again, we come back to, speed and ambition on greenhouse gas reductions. It might not necessarily be the cheapest and most efficient build out of the energy system.
And to be clear, you're not saying green hydrogen isn't a great thing. You're just questioning the sort of timing
Exactly.
of building up this capacity.
Absolutely. So we're also looking into green hydrogen solutions. But of course, being an upstream focused company, what we have been trying to do is really look at where do we have a contribution to make, and which contribution will have the most significant impact on greenhouse gas reductions. And so that's why we have come with CCS and blue hydrogen up front, but we are definitely also looking at the possibilities for green and how that can be integrated. So we in a way see the solutions, the low carbon solutions that as we call them, as a foundation, as a springboard, if you like, for green solutions coming in when they are more commercial and ready.
John, what do you think of the 40 gigawatts of electrolyzer capacity? Is there some way you could put that in context of offshore wind farms or something?
Yeah. When we looked at the numbers in the EU hydrogen strategy, we struggled to get a production of 10 million tons from 40 gigawatts of electrolyzer capacity. So we're not sure what kind of renewable load factors they've assumed in that calculation. We think it would need to be in excess of around about 90%, which obviously is unachievable from any renewable source. So based on some of our calculations, we think in order to produce that 10 million tons with that 40 gigawatt, you'd need over 120 gigawatt of offshore wind capacity, for instance. And to put that in context, that's equivalent to around about what Germany has installed in renewable capacity at the moment. And remember, we're talking about 2030, we're talking about 9 years away. So we're talking about that amount of renewable build to support that electrolyzer capacity, and the manufacturing capacity doesn't yet exist for those electrolyzers. So the scale of that challenge is pretty staggering. And that 10 million tons of hydrogen as well would only be enough to replace what we currently use as grey hydrogen. So that's not making any inroads into the other sectors that we think we can decarbonise. And just, to support Johan's point again, if we can produce blue hydrogen, we can start to move a lot quicker. We can start to have an impact on emissions much quicker than if we wait for that amount of offshore wind electrolyzer capacity to be put in place.
Yeah, and I guess the only way they could be getting to a 90 plus load factor is also assuming a huge amount of battery storage put in place with the renewable, which sort of would be a staggering amount of battery storage as well. Johan, just talking about the amount of investment required, the EU strategy has got around 450 billion euro of investment outlined. What's going to be key, do you think, to attracting private investment to this sector?
We touched upon it a little bit earlier as well, but of course the obvious thing is to provide a kind of a long-term stable framework for the business. And in that regard, I'm mostly thinking about demand side incentives, pushing at least some of that money into incentives whereby you would create demand for low carbon steel or low carbon products in some shape or form, so that potentially you close the gap on the consumer side more than on the producer side. I think money is cheap these days. We already alluded to the fact that there is not really a technology challenge on the production side, also not for electrolyzers. I mean, we know it. I mean, it's about scaling up and bringing costs down. But I would argue that the most important thing to do is to create that demand side incentive, create that market, and then it will become more attractive to also invest on the production side.
And John, and then maybe Johan, you could just close out. What do you think should be the next steps to kickstart the hydrogen economy?
I think certainty. So just picking up on what Johan was saying about trying to encourage investment, it's certainty that's going to give that incentive. So I think what do we need? What do we need to do? We need certainty over the support mechanisms that are going to be in place. So a bit more clarity about what some of those support mechanisms might look like. What might a carbon contract for difference look like? Does it apply at the production end? Does it apply at the demand end? How do you, or what is the process of applying for carbon contracts for difference? So we need some more clarity about what these support mechanisms are going to look like. But we also need clarity as well about what the EU and what some of the national governments are going to classify as low carbon and renewable hydrogen, because I think there's a little bit of a grey area there at the moment. I know the EU has scheduled work on that to take place during 2021, but the sooner we have that clarity, the better as far as I'm concerned.
Use of the term grey area not terribly.
No, and indeed it is so. I mean, the EU is, or at least the European Commission is really diving into the legislative environment and trying to figure out, okay, what is now needed in terms of additional definitions, of additional legislation, of additional enablers to kind of make that market happen. And we are expecting at least that by Q4 next year, we will have a little bit more insight as to how a hydrogen market will look like.
Yeah, well, it's certainly something that is very necessary from what we see as well, and it's a fascinating subject, the hydrogen economy and how that develops, and it's something that's not going to go away anytime soon. I'm sure we could talk for a long time about the subject, but I'll draw it to a close there. I think hydrogen vital for the future, and decarbonisation, of course, so important as we look forward. So I'd like to thank you very, very much, Johan, for joining us.
Thank you for having me.
And John, thank you.
Thank you. It's been a pleasure.
And thank you very much for listening. I hope you enjoyed that as well. I certainly did. And please subscribe. This is Fueling the Transition from AFRY Management Consulting. Bye-bye.